Hello and welcome to the final part of the Pico ESP32 series. Now you may have seen how similar this series has been with other tutorials that I've done regarding BLE. You've seen me do it with the Raspberry Pi and the Pico, the Raspberry Pi and the ESP32, and now the Pico and ESP32. So let's wrap things up like we've done with the previous series by moving on to button control. I will show you how to send messages from the ESP32 to the Pico W and then turn on and off an LED as we've done before. This will also be accompanied by a Medium article in the description along with the GitHub repo. And I do have a surprise to talk about in a bit, but I will want to say that there will be a future collaboration as in with PCBWay, but I will wait for that until my boards arrive, so stay tuned for that in the future. So let's get started. The setup is exactly the same as before, and I will link the Medium article that covers the setup. Basically, we need to get AIO BLE installed on the ESP32, either automatically or using the tools option in Thonny. So you'll go here and manage packages, for example, and then you can install the packages you need. But I didn't do that. As you can see in the libs directory, I installed AIO BLE by myself using the manual installation. And to do this, you'll need to copy the AIO BLE folder from the MicroPython libs GitHub repository and make sure to copy it to a directory called lib. On the Pico, everything is set up. You don't need to do anything. AIO BLE is already included by default. So let's take a look at the wiring diagram first. Now I need to make one correction that I should have made since the very beginning of the Raspberry Pi and ESP32, but this module I used is not the correct one that I have. I had suddenly realized that. However, the pin numbering is exactly the same, is still the same, 15, 19, so it doesn't matter. If you have a different ESP32, it should work just fine. And in fact, you don't even have to use the exact pin I'm using. You can use a different pin, for example, pin 17, but you will have to change the code, and I'll explain that later on. But yes, I do apologize for that. In fact, I even checked, I have the 30 pin variety. This is the 38 pin. But I did find the correct one for fritzing, which I had to use because this one didn't work for what I wanted to do with my circuit board design. So I did find the correct one. But regardless, despite this hiccup, this should still work. So whatever ESP32 module you'll be using, you can use any pin you want. Just make sure that that you still use ground for this project. And as far as the Pico, thankfully this is still correct. So let's take a look at the ESP32 first. So you'll have pin 15 on one leg of the button and ground. So you'll still need ground. Now you can change this to any other pin you want. Just be sure to change that in your code. On the Pico, now we have one leg of the LED to pin 0 or GP 0 and the other to ground. Now I'm going to use a panel mount or a PC style LED from a hard drive LED that I have, but it's pretty much the same concept. So again, I should have realized I used the wrong module, but it still works regardless. Anyways, so let's get to the code. We'll start with Pico. Now with Pico Central, it's exactly the same. Nothing has really changed at all, except maybe a slight time change here at 0.1 seconds for the button, but everything else is still the same. Nothing has changed at all. However, what has changed is Pico Central LED. Here we have our red LED at LED 0 because we had to import it from here, so make sure to add this. And otherwise, we go down to receive data task, and if our data is 0, then valid red is on, and if it's off, then if it's 1, then it's off. And that's it. So let's move on to the ESP32. As I mentioned, we have our libraries here, including we have to import a pin, of course. Here's our button. Now make sure to change that if you're not using pin 15, like I said before, and we need our button to be a pull up. If we were using 3.3 volts, then it would be pull down. Everything else is still the same functions, except here. So if our button value is 0, we'll send the message 0. If it's 1, then we'll send 1. So if we press it, it sends 0. If we let go of it, it sends 1. So essentially, if the button's not pressed, it's 1. Now with a pull down button, it's the opposite. So if the value is 1, then the message would be 1, essentially if the button's pressed. And if it's not, then it's 0. So be sure to take that into consideration. But everything else is still the same for the code. Nothing has changed at all, except for these lines here and also adding the button. But everything else is still the same. So that's it for the setup. And now let's get to the demos. Hey guys, so we are now running the code here. As you can see, I have the Pico and ESP32 running. So if I press the button on the ESP32, you can see it update. Let me do that again. When I'm holding it, there you go. So now we have the code running just fine. So let me exit out of this. So I'm going to exit out of the ESP32 first. And let me exit out of the ESP30 of the Pico. And that's it. So let's move on to the second demo. Hey guys, so here's the demo running now. So you can see the screen here. This is when I press it, and you can see it working. Let me press it again. And there you go. So it works just like always. And yes, you can see the LEDs are blinking, which means it's working properly. So that's it for this very quick demo. Thank you for watching this series from beginning to end. Now, like before, you can use this to control a robot, for example, and even combine a potentiometer for speed control, which I will do in a future series in the future. But the next series will involve using the ESP32 as the central device and the Pico W as a peripheral. Stay tuned, and I'll see you next time.